Okay, the next little tutorial that we'll be looking at today is how you're going to analyze your blood flow data after you've done an FMD protocol. So in your file, first off, the FMD protocol is the first thing we do in your file. So if you look at the time along the bottom, it probably takes me about 5 to 10 minutes to get a good signal and then to inflate the cuff. So that means in your y-axis here, you'd probably be around 5 to maybe 900 seconds. You'll see this type of pattern. Your flows are in, or your velocities are in these two channels here, channels 2 and channels 3. This one generally refers to reverse flow, and this one generally refers to forward blood flow, just depending on the setup of the Doppler. So what you can see is you've got a somewhat biphasic flow, with a little bit of activity here, followed by reverse flow, followed by a little bit of forward and a lot of reverse. So you'll see this pattern before actually we release the cuff. So it should continue for about 300 seconds, which is about 5 minutes. So if we scroll forward, we'll notice that abruptly there's a large increase in the activity in this particular channel, channel 3, and that indicates that we release the cuff pretty much at this time point right here. So to use the macros that we've already built and are already in each of the files, I need to insert a comment at this time point. So what I do is I click on the timeline on the bottom and I make sure I'm lining up with the start of the cuff release time. And I click there and I go add a comment at that time point. So to do that, I go comments and exclusions. Sorry, I go to commands, add comment, and I type in cuff release. It's important that this is spelt correctly because what the computer is going to do is locate where this comment is in the file and then subsequently analyze the data from that time point. So once you click add, that adds in a little comment. Similar if you remember when I was asking people to type into the computer during our collection and pressing enter, that would add a comment at a specific time. So once that comment is actually in the program, for this particular macro to work, you need to click beyond that comment, so in this part to the right of the comment, somewhere in the workbook. What you're going to do is run one macro. This particular macro highlights 0.1 second time intervals and then subsequently moves 0.1 seconds across this whole signal for 120 seconds. Every time it highlights 0.1 seconds of time, it dumps information into your data pad. Specifically, it'll dump what we need is the frequency power and the power of the signal, as well as the start. So keeping that in mind, what happens is we run the macro, it analyzes channel 2, and then we run a different macro, and that will analyze channel 3. What you'll get in your data pad then is 120 seconds worth of data relating to channel 2, and then after that one you'll have another 120 seconds of data relating to channel 3, or the forward direction blood flow. When you take this information into Excel, you can then calculate out using the blood velocity template the actual velocity of blood going through, or the speed of the blood going through that particular vessel. So getting back to this here, what I'll do quickly is just give you an example. I'll run this. The computer highlights the whole area of 120 seconds. Then it'll sequentially go through the whole data set for 120 seconds. So you'll end up with about 1,200 data points relating to the blood velocity in the reverse direction. Then what I do after it's finished running the macro on this particular channel, I click and actually do the next particular FMD velocity, which will be determining velocity on the other channel. So if I click this, you'll notice it highlights the other channel, channel 3, and then sequentially goes through that whole channel. So we're just going to let this run for a little bit and then escape out of it. Anytime this isn't done right, you can just hit escape on your keypad and it'll pretty much end the macro at that time point. So I hit escape now. I'll open Excel, and specifically I'll open up my blood velocity template, which if you don't have it, just email me and I'll give it to you. blood velocity template, this one here. Now this template has all the equations that you need to calculate blood velocity from a particular signal like this one. To do it, what you're going to do is take the information from the data pad, which is here, highlight this all the way down to the end of your file. So from here all the way to the bottom, I've copied it, and copy selection, go into datapad, or sorry, Excel, just maximize this, and dump it in over here. So what you have are a series of cells that are important and some that aren't. So this particular column is just the duration that you were selecting, which isn't important. These are related to tonometer values, which you're not taking measures of at that time, so they're not important. Finally, this value here is also not important. This is the amplitude. So what you have is time, and you can notice every 1/10 of a second that time goes up. You also have mean frequency, or the frequency power, and the power in that signal. We let this macro run for a series of times, so what you'll see is after about, I guess it was 20 seconds or so, you see the time return back to the beginning of the time of, well, basically where a cuff release was released. So you need this information, and you need to align this channel information with this information. So to do that, you're just going to put them one beside the other. So I've copied this area. I'm going to go over here into my template and paste it right here. And then I'm going to go down and select just the information pertaining to frequency power and power, and I'll copy this and then align it up at the beginning of this particular thing with the other data that you have. So by copying it into forward mean frequency and forward power at the same periods that we have, we can calculate net velocity. So if I hit paste it in right here, it applies a Doppler equation, which you can look at up here. Actually, it's wrong in this particular case. So 68. Enter. Do the same thing here. In your template, this will definitely be correct. Radians. Enter. Oops. Drag that down. There we go. So now that I have the correct equations in this, these two boxes, the Doppler equations, I can now calculate the weighted velocity, so really how strong the signal was in the backward velocity and how strong the signal was in the forward velocity multiplied by the actual velocity. So if we look at the math, what we have is backward velocity times power and forward velocity times power. If we subtract one from the other and divide by the total power, we can determine net velocity. And if I were just to highlight this column here, for the time that we actually analyzed from datapad up to about 529 seconds, you'll see that on the left side of the screen now. There we go. This is the data that I've just analyzed, and I create a line graph. We should get what looks similar to what we see on the screen on the Doppler when we're collecting it, and that's right. So basically it looks like a lot of blood pressure waveforms, but in this case you have a y-axis which is in centimeters per second, which is a velocity, and the x-axis being time. So we have speed of blood flow, or average or mean blood velocity over time. Now to get an average of, say, that time period, you would simply take an average of that column. When you're analyzing your data, you should do a couple of different averages, one being a 60-second average, and that's about, and maybe one being a 90-second average, and then you should calculate from that shear rates using 8 times mean blood velocity divided by diameter. So once you have all that information, you'll have exactly what you need to determine blood velocities after you release a blood pressure cuff. That's it for this particular tutorial. So hopefully that'll get you guys started, and if you need anything, you know who to talk to.